Hello, my students and viewers at home. Once again, you are welcome to online teaching from St. Charles College, Onitsha. Your teacher is Mrs. Anosike Josephine from Chemistry Department. Our subject of discussion today is on preparation of salts, the liquescent, efflorescent, and hygroscopic substances. Specific objective of the lesson. This means that these are the areas we are going to discuss for today, so that at the end of the lesson, the students, will be able to 1. Define soluble and insoluble salts. 2. Give examples of soluble and insoluble salts. 3. State the methods of preparation of soluble and insoluble salts. 4. Outline the laboratory procedure for the preparation of a soluble salt like copper sulfate and an insoluble salt like lead 2 chloride. And finally, explain the meaning of the following terms: the liquescent, efflorescent, and hygroscopic substances. Now we get into the lesson proper, solubility of salts. There are certain salts, when you add them in water, they dissolve, and we call them soluble salts. While there are others, when you add them in water, they don't dissolve, and then we call such salts insoluble salts. This takes us to 2 categories of salts: soluble salts and insoluble salts. What are soluble salts? Soluble salts are salts that are soluble in water. They form homogeneous solutions. In homogeneous solutions, the solute particles are not seen. What do we mean by that? It means that when you add the solute, the solid particle of the salt inside water, it dissolves and then interlocks with the molecules of water evenly or orderly, thereby making the particles invisible to the eye. The only thing you can notice, or what is visible to you, is the color of the solution. Now, when you look at the screen and you see the picture on the screen, you see the solid salt, copper sulfate, being dissolved in water. At the end of the dissolution, you have a liquid that is blue in color. The naked eyes could not dictate the solid particles any longer because the particles interlocked evenly with the molecules of water. We call such solutions uniform solution. The other type is the insoluble salts. These ones don't dissolve in water. And what are they called? They are described, or they are defined as salts that are slightly or completely insoluble in water. They form what we call heterogeneous solutions or ununiform solutions. What do we mean by that? It means that such salts, when you dissolve them in water, some quantity, a little quantity of the salt will dissolve, that is, interlock with the water molecules, making the medium cloudy. No more, the liquid water will not be transparent again. But majority of the salts will now settle at the bottom of the beaker because it did not dissolve. You look at the screen and see a typical example of a salt that is insoluble, lead 2 chloride. After dissolution, we have a cloudy medium because a little of this salt dissolved in water, while majority of them did not. We have another type of insolubility that is not as a result of its inability to dissolve in water. This type of insolubility is caused by chemical reaction between 2 salts. 2 soluble salts will react to produce the solid, and we call such salts precipitate. If you look at the screen, you will see the difference between a precipitate and an insoluble salt. In the precipitate, all the particles have almost engulfed the liquid medium, giving no boundary between the liquid and the solid. But when you look at the insoluble salt, there is clear boundary between the liquid medium and the solid particle. We now come to methods of preparation of salts. There are many methods of preparing salts. We prepare salts in the laboratory and also in the industry. When we prepare salts in the laboratory, we prepare small quantities for chemical tests. But in the industry, we prepare large quantities for commercial tests. The methods of preparing soluble and soluble salts are not the same. So we now look at preparation of soluble salts in the laboratory. There are three main methods of preparing soluble salts in the lab. The first one, by neutralization reaction. That is reaction between an acid and a base to form a salt and water. You can see the equation, the acid reacting with the base to form the salt, sodium chloride. The second method is action of a dilute acid on a triiosocarbonate for salt. Last time we talked about salts we call the triisocarbonates, those salts that contain CO3 in their molecule. Now such salts, when you add acid to them, they release a gas, a colorless, odorless gas we call carbon 4 oxide, CO2, in form of effervescence. If you want to understand what we mean by effervescence, you open the bottle of Pepsi. That particular experience you have, a gas given out, is exactly what happens. So in the lab, when you have the test tube containing the carbonate and you add the salt, the acid, there will be effervescence of a gas coming out from the test tube, just like that of from the bottle of Pepsi. Then the third method is action of a dilute acid on a reactive metal. There are metals we call reactive metals. If you look at what we call electrochemical series, there are these arrangements of metals and non-metals according to the one that is more reactive. The ones we call reactive metals are those ones that are both hydrogen in that series. Example, calcium, potassium, magnesium, iron, even zinc. When such metals react with acid, they normally produce hydrogen gas. They displace hydrogen from the acid. Now we come to a typical preparation of a soluble gas in the laboratory. That is what we can do in order to prepare that. So we have here laboratory preparation of soluble salt like copper 2 sulfate crystals. We are using the method of neutralization method, that is reaction, the first method we discussed. Reaction between an acid and a base. Now when you look at the screen, you will see that we have 4 stages to prepare this salt. Having organized your apparatus in that order, the first stage is you now add the acid inside the beaker and then put the base. In this case, our base is a black salt called copper 2 oxide. You add it and stir. Then you now carry it and put on the source of heat, as you can see, the second stage. You keep on stirring and allow the heat to heat it up. You allow the flame to heat it up. This particular procedure is used to make sure that the salt dissolves faster. It keeps on dissolving and dissolving. You keep on stirring until at a stage the solid particles cannot dissolve further. That time we said that the solution is now saturated, and you know it will be hot at that stage. So you bring it down for cooling. When it has cooled, you go to the third stage and pour the whole mixture into the filter. You want to filter, filtration stage. This filtration stage, you are supposed to produce 2 things, the filtrate and the residue. The residue is the solid part of the solution mixture, and the filtrate is the liquid part. We don't need the solid part. So once you filter and the solid part rests on the filter paper, you keep it aside and concentrate on the filtrate. That is where we have our soluble salt, that blue solution. Then what you do next is to return it back to source of heat for what we call evaporation. You want to crystallize it. You want to remove the water molecules in it. And when the water molecule goes off, you are now left with the solid particle, copper 2 sulfate crystals in the crucible. Then you expose it to dry. Either you expose it to the atmosphere, or you put it in the crucible in the lab or in the oven. It dries and you quickly get your crystals of the soluble salt. Now when you look at, you can see the various steps. We have just decided to give you an outline of how it happens. First stage, place about that amount of acid in the beaker. Then second stage, you add insoluble salt while stirring. All those things I have explained before. Then the third stage, you filter the mixture and heat the filtrate to recover your crystals. Then the fourth one, you now get your blue crystals, as you can see. Then remember to write the equation for the reaction. the reaction with the base and the acid reacting to give you the salt and water. Now we go over to the other group or the other type, insoluble salt, their preparation. I have told you that you prepare insoluble salt. The method you use is different from the preparation of soluble salts. In insoluble salt, we have two methods. The first one is by precipitation reaction. Already I have mentioned the word precipitate, and you know how the salt looks like. Now, we want to discuss how we can prepare an insoluble salt like lead 2 chloride in the lab. If you look at the screen, you now see the diagram. There are 4 stages. In this reaction, 2 soluble salts, lead nitrate and sodium chloride, reacted by double decomposition to form the precipitate, lead 2 chloride. You pick the first stage. In the first stage, you now mix the 2 salts, the sodium nitrate and sodium chloride, these 2 soluble salts. You mix them up. Initially, it looks as if nothing is happening, but after some minutes, you begin to notice white particles appearing. These white particles are the precipitate of the insoluble lead 2 chloride. You keep on stirring and allow more precipitates to form until at a stage the reaction will be complete. No more precipitate forming. Then you move to the next stage. One thing you have to notice here is that we did not heat anything. There is no heating in this reaction. You now go over to the second stage, where we want to recover our precipitate by filtration. We now filter. We have the filtrate and the residue, which is our insoluble salt. After filtration, it is obvious that all the liquid, the soluble sodium nitrate, did not run off. We now have to purify it by using distilled water. We now go to the third stage. In the third stage, we pour distilled water inside the insoluble salt, the precipitate formed, and it will rinse off any sodium nitrate remaining with the precipitate. When you have done that, you are now with your clean lead 2 chloride precipitate salt. You now expose it to air, or you put it in a desiccator where you can now dry it. At the end of the day, you recover your insoluble precipitate lead 2 chloride. As you now look down, you now look at the procedure, an outline of how you can write the procedures we used in the lab. The first one, you place 25 cm cube of the solution in the beaker and add the sodium chloride solution. You stir and no heating. A white precipitate is formed. Second stage, the mixture is filtered to get the precipitate. Third stage, the filtered precipitate is rinsed with distilled water. And finally, the fourth stage, the insoluble salt is placed in the crucible and dried in an oven. That is how we can get our simple lead 2 chloride in the lab. Then the other method, that one is simply direct combination of a metal and a non-metal. Reactive metals like iron will react with a non-metal like chlorine in form of its gas to produce the salt lead 2 chloride. And this lead 2 to produce this iron 2 chloride. This iron 2 chloride, remember, it is an insoluble salt. Now we come over to definition of terms. There are certain salts, when you expose them to the atmosphere, they gain weight because they absorb some moisture from the atmosphere. And there are some of them, when you expose them, they lose weight because some amount of water left their molecule, their structure. This type of phenomenon has given rise to definition of certain terms like deliquescent substance, efflorescent substance, and hygroscopic substance. We now look into the first one, deliquescent substances. What are they? Some compounds, when exposed to the atmosphere, absorb a large amount of water or moisture so that they turn into solutions. What we are saying here is that these type of substances or compounds, when you expose them to the atmosphere, will trap molecules of water from the atmosphere, from their surroundings. They will trap it in such a way that they can even dissolve in it to form solutions. Such phenomenon is what we call deliquescence, and such compounds are called deliquescent compounds or salts. Examples are calcium chloride, magnesium chloride, sodium hydroxide, potassium hydroxide, and the others. The second category are the ones we call the efflorescent substances. A process whereby a hydrated salt loses its water of crystallization partially or completely to the atmosphere is called efflorescence, and the salt is called efflorescent substance. What do I mean by that? These substances, when you expose them to the atmosphere, they lose their water of crystallization. Only salts that are hydrated salts do this. They lose their water of crystallization to the atmosphere. Either they lose all of them or they lose part of them. So if it is partial, you will know from the chemical equation, and if it is completely, you will know. Now let us look at the examples we have on the screen. You have the first salt with 10 molecules of water. After exposure to the atmosphere, 9 molecules got lost, leaving only 1 molecule, showing that partially, at least, that salt has 1 molecule of water remaining in this molecule. So that is partial type of loss of water molecules to the atmosphere. Then the second one with 5 molecules of water. You can see from the equation, all the 5 molecules of water left the molecule, changing that salt to what we call anhydrous salt. It doesn't contain any other water again. So that that salt is no more a hydrated salt. You don't have even a half molecule of water in it. While the other one, even though it is warm, it is still a hydrated salt. So compounds of this nature that lose water to the atmosphere are called efflorescent substances or efflorescent salts, and that phenomenon is efflorescence. Then the third group and the final one is the one we call the hygroscopic substances. These ones tend to behave like the first one, deliquescent, but with some differences. In hygroscopic substances, they normally absorb water from the atmosphere. That is quite all right. But they don't turn into solutions like the first group. Rather, if it is a solid, the solid becomes sticky to tell you that it actually absorbs some amount of water, but can never dissolve in it. They are sticky. Then if it is a liquid, they get diluted. Like a typical example, concentrated H2SO4 is a very good hygroscopic substance. When you expose it to the atmosphere, it absorbs some amount of water, diluting itself. That is, now the volume will be more. It is no more like when you had it in the bottle, when you closed it. But this time around, you expose it, it will absorb some amount of water to get diluted. Such compounds are called hygroscopic substances. Examples like copper oxide, you have calcium oxide, concentrated in form of a liquid, concentrated H2SO4, and others. Then one thing about this group of compounds is that they are always used as drying agents in the lab. When you have prepared salt, any of these substances can be used to dry the salt because it is not going to dissolve in the salt. It will just remove the water molecule from the salt and leave the salt dry. Finally, we have come to the end of our lesson for today, and we have to evaluate ourselves by answering the following questions. Number 1, list 3 types of chemical reactions suitable for the preparation of soluble salts. 2, which of the following salts is not prepared by precipitation process? Lead carbonate, calcium carbonate, potassium carbonate, barium carbonate. Number 3, consider a reaction represented by the following equation. What name is given to this type of reaction? Then finally, number 4, define the following terms and give example of a salt which exhibits each of the phenomena: efflorescence, deliquescence, hygroscopy. Submit your assignment through my WhatsApp contact 08037413649 at St. Charles College, Onitsha. I repeat again, 08037413649. Thank you for listening. Goodbye. See you again.